So I'm going to talk about 10 minutes. Tom Smith's kind of going to give me an 8-minute marker, and then we'll pass the mic over to John to give the second part of the briefing. And I wanted to give a little background. Over a decade ago, I started a series of research seminars, community college students, and it evolved into high school students also taking the course. So it's a one-semester course. The requirement from the very beginning is publish or perish. So the students had to have an actual paper published in a journal or a book, or they didn't pass the course. And essentially all the students that did have were co-authors. They all got A. So it was a kind of an A or F sort of situation. So we started out actually in when I was living in Arizona, and we started out for quite a number of years doing variable stars. The pictures on the bottom, the lower left and the lower right, these were actually stars that Eric Crane suggested. Remember that, Eric? What happened to Eric? Oh, he walked. He was afraid. At any rate, the students discovered a number of variable stars. But the problem was with doing extensive CCD observations from my telescope at my place, that the cost of pizza for the students and the rating of the refrigerator, and they kind of took over our house for a semester. So we decided we needed less observation. It was a little tough on the students. And so we decided to try another area, and we tried double stars. And you can do double star observation. This is a Castor in Gemini, and you can see the green clear over on kind of the far left there is that's Herschel's first observations back in the late 1700s, and so the position, angle, and separation of the stars change over time. Then you can see some kind of pinkish ones showing up. So these are photographic instead of visual observations. And finally, you get some blue ones down in the end, and these are speckle interferometry. And so for students, you can use a simple eyepiece. It's under $200. Celestron makes a real nice one. They just stopped making it, and Meade has one that's quite nice. And this and a telescope is all the students need in terms of observational equipment. And we found in our seminar that students really like, while robotic observations are fun, and we've done that in our program, students also like to at least have some on-telescope observation. They like to get their eyeball up at the eyepiece and write numbers down. And so that seems to turn them on. So these are some of the classes we've had. And so this has been going on, like I say, for about a decade. It kind of morphed into mainly being high school students, mainly AP physics and chemistry and math students, would sign up for this research seminar as a college student. So for many of them, it was their first college course. They end up with a published paper, and the word got out to other students that took Russ Genet's essentially non-transferable research seminar, why should you take it? Well, the students got scholarships and got into choice schools because they were published scientists, if you will. And this really impresses administrators. So here's some more of the classes. So as they've been, and more classes, lots of fun over the years. Lots of the students I've kept in contact with. They're starting to move into their graduate, and some have started into the PhD program. So I supply them with letters of recommendation and so forth. This last fall. I just do it once a year. So this was the last class, and this is their observation night. This is a cooperative program with amateurs. The amateurs supply the telescopes and operate the telescopes. Getting the students to actually learn to operate telescopes takes a bit of time, and so we have amateurs do that. Here's a typical first draft paper. We have extensive internal reviews. The author of this paper, Mark, why don't you stand up and wave your hand? That's Mark. And and this is after, how many times did you rewrite that, Mark? About 8 to 10 rewrites. And after 6 or 7, then it goes out for external review. We send it to top scientific experts in the field, and they have a hack at it, and eventually goes off for publication. This is Joe Johnson. How many of you remember Joe Johnson giving a talk here? Okay, quite a few do. Well, he graduated Sunday and from Chico State. He has over a dozen published papers now, co-author of 2 edited volumes, and he's going on to PhD. And so anyway, he's one of our star students. We spread the seminar approach. We started doing, instead of a semester-long class, we've been holding up at Pine Mountain Observatory. This is the Pine Mountain Ant. It's in east of Bend, Oregon, so it's the University of Oregon's observatory, and we've been holding seminars up there every summer. It's kind of a long weekend, and it's very intensive. The students come in. Within hours, they're giving their first PowerPoint briefing of what star they selected and what research they're going to do. They make the observations, they do the analysis, they write and rewrite the papers, and then they have an out briefing, and their papers get published. And so this is all in a long weekend, but it is pretty taxing. And I decided this past winter to extend this to Hawaii. I spend the winter in Hawaii every year. And so this is Leeward Community College. You can see in the upper right, it's at about 10 feet above the sea level, and that's Pearl Harbor in the background there. They have a very nice 20-inch telescope, and we actually did CCD double star astrometry, and the paper should be off for publication in a few weeks. And then went over to Maui, and this is the Fox Telescope North, and John will tell you a little bit more about this telescope. John Pye, where's John? Somewhere high, there he is back in the corner. So you can see John and myself in the picture. And what we did is we formed a group of primarily middle school and high school students to be double star observers. And here's the Maui double star observer group. And the older gentleman, kind of the tall one, that's J.D. Armstrong. He works for the Las Cumbres Observatory and also the Institute for Astronomy in Hawaii. And Steve McGoffey is the guy over on the right. He's a visual observer. The amateurs, there's Steve up. They have an amateur club observatory at 10,000 feet on the summit of Haleakala, paved road to the top. It's the most wonderful amateur observing site, I think, on the planet, bar none. Yes, okay, 8 minutes. That's good. Okay. Going beyond making observation with a eyepiece, kind of the next step up is to use kind of regular CCD cameras. Bob Buckheim has done work on when stars get close, when you take a CCD image, how do you kind of tease them apart. And then the next step up from that is Lucky imaging and speckle interferometry. And so the upper left there is a 32-inch telescope. Actually, Cal Poly students did lots of design and building. And you can see there's John, lower left. We've got an EMCCD camera, and we're doing about 30 frames a second. The electron multiplication keeps the read noise down, and we get speckles. So the lower right is a typical speckle pattern. Here's results. For Lucky imaging, you see these top 3 images on the left. These are the sharpest out of many thousands of images, and the ones on the bottom are the least sharp. The top right is just taking the first 200 images, and this is out of 5,000. And the one on the bottom is taking the sharpest 200. And you can see what a difference. There's a slight ghost image up at the 2 o'clock position of the star, and that's a little bit of an artifact from the processing. And then speckle interferometry. And so a single speckle shown in the upper left. Down below is 1%. So this is 1% of the 5,000 images stacked together. That's the best you can. The upper right is just a flat 10-second integration. So this is what you would get with normal cc. And then the lower right is a speckle interferogram. And from it, you can get the separation and the position angle, and it really overcomes seeing. So you can actually get it down to the resolution of the telescope. And so the bigger the telescope, assuming resolution optics, the closer you can get. So you get down, 20 milliarc second separations, things like that. So you can get in with binaries with very short periods. Doing this requires low read noise, so you need an electron multiplying camera if you're going to do faint stars. That's my telescope, and that's a same kind of camera that they use, very close to the camera that they use at Las Cumbres Observatory. So I'm just getting started on lucky image and speckle interferometry. The other technique, well, there's two other techniques. One is called amplitude interferometry, and it's like what Char uses and what they have out at Anderson Mesa up in Flagstaff. And these are separate telescopes, and they bring the light together, and then they have these laser-controlled trombone adjustments. They're very expensive. But there's another approach called intensity interferometry, where you just essentially have fast detectors like a fast PMT at focus, and then but you need telescopes that you can move, and you can move the telescopes apart. This was first done by Hanbury Brown in Austria, and that's this picture here. And what we're doing, we're putting the finishing touches on a portable 1.5 meter telescope at Cal Poly, and that's a picture of the telescope. There's me and the students, engineering students, putting the telescope together, putting the truss on it. Still got a ways to go. I actually hope to bring it to RTMC this year, but it's going to be next year. I wanted to make sure it was actually operational and doing science. And finally, we have a conference in Maui in February, and I've got flyers, so anyone interested in coming, all would be welcome. We're holding it at the University of Hawaii's Institute for Astronomy there. Before the conference, we're going to do a submarine cruise out of Lahaina, tour the old town. We're going to go up, spend a day on the summit of Haleakala. There's Pan-STARRS. It's a real compact, it's a really amazing observatory. There's the Fox Telescope North. There's the amateur site, and you can see the Fox Telescope North in the background. They have a place to see oversight. It's very nice. And we're going to wind up the conference at the plantation for our Aloha dinner. And at any rate, you'll all be welcome. And over to John. Did I make the 8 minutes, Tom? I mean the 10 minutes? No.
Thank you, Russ. It's kind of hard to follow a description of a conference coming up in Hawaii, but we'll see what we can do here. For some reason, those slide backgrounds are not showing up, but I hope that doesn't continue. I'm Senior Project Manager for Las Cumbres Observatory. We're headquartered in, well, looks like I've lost all of my backgrounds for some reason. In Santa Barbara, California. We are building a network of global telescopes. We're a privately operated nonprofit foundation. We have an ambitious project of distributing a global network of identical telescopes. And the mission, scientific mission, is to conduct time domain astronomy, things that go bump in the night over a relatively short period of time. Lots of the things that were discussed at this conference fall into that category. Transiting exoplanets, supernovae, active galactic nuclei, and near-Earth objects. We'll probably get into lots of other interesting topics as well. We have mechanical engineers, electrical engineers, just about every kind of engineer you can imagine, including software engineers who are very overburdened trying to write about 1 million lines of code to operate our network. And so here you can see the global distribution of our sites. Each one of these sites will have multiple 1 meter and 0.4 meter telescopes. In some cases, there'll also be a 2 meter telescope. And the whole idea behind our network is that at least 1 or 2 sites will be in the dark. And so I've got a little illustration here that kind of shows a nighttime band moving across the sky, the world, and you can see that at least 2 or 3 sites are always in the dark. And so this leads to our motto of "We keep you in the dark." So, how many organizations can actually make a claim like that and have it be a good thing, except maybe politicians or something? So here's a picture of the 3 types of telescopes that make up the network. You've got the 2 meter telescopes, which we have 2 of. One Russ talked about. It's the Fox Telescope North in Maui. The middle one there is the 1 meter telescopes that we're actually designing and building from scratch, and the 0.4 meter telescopes. All the telescopes are, well, the 1 meter and the 0.4s are actually built on the idea of a split ring, old Porter style mounting, which is a very, very stable kind of equatorial mounting. And the real challenge here is to build and distribute these telescopes and observatories in some sort of identical fashion, all the way down to mounting control systems, software control systems, instrumentation, filters, so that we really have a very good, highly calibrated photometric network that encircles the globe. The 1 meter telescopes are made from a cellular mirror design. These mirror blanks are actually made by Hextech. They're fused parts, which are then ground and polished into an F8 Ritchie-Creation design. Here are some of the split ring 1 meter equatorial mounts under fabrication at our plant in Santa Barbara. Picture of one of the 1 meter prototypes that we have operating in Santa Barbara in our parking lot. Here's our first, one of our first deployments. This is at CTIO. We're going to have 3 1 meter telescopes deployed. These observatories are currently empty, but in a couple of months they'll be filled with 1 meter telescopes that will be hopefully operating shortly. This is our first 1 meter telescope deployment. This is in the observatory at McDonald. It is currently undergoing engineering commissioning. This is looking south behind the telescope. The telescope sort of pointed at the meridian and the ecliptic. And you can see the instrument package on the back end. And one of the things I like to brag about on this telescope is how neatly it's cabled on the backside. Of course, it is young. And the 2 meter telescope in Maui that Russ talked about, it's an F10 Ritchie-Creation design. It was not built by us. It was actually acquired. The 2 meter telescopes were acquired by us. Everything else we build from scratch. But the 2 meter telescope has a nice array of instrumentation, including a couple of wide field CCD cameras, a Merope, and a spectral, and a couple of high-speed electron multiplying telescope imagers, both of which we hopefully will be using for future double star observations. And there's also a low-res spectrograph that was just recently deployed last week and is undergoing commissioning. And that's a little bit of an introduction to Las Cumbres Observatory. Thank you.